Okay, we are going to linearize this function. Okay, we are going to linearize 2 to the x at a is equal to 4. Okay, we're going to linearize 2 to the x at a is equal to 0, and here we have the formula, so let's just go ahead and get to work. So let's plug in 0 in here. We get the f of 0 is just 2 to the 0, which is just 1. And then we need the Alright, here we are going to just here we are going to linearize this. Okay, we are going to linearize 2 to the x at a is equal to 0, and that's okay. Here we are going to linearize 2 to the x and at we are going to linearize 2 to the x at a is equal to 0, and here we have the formula. Let's go ahead and get to work. First, we compute f of 0 because that's f of a, and we just get 2 to the 0, and that's just 1. Done. Next, we need the derivative. Okay, differentiating 2 to the x. Well, we have to remember our derivatives really well. For this one, we get 2 to the x, but we multiply by ln of the base, which is ln2. So be sure you have that. And then we will just find out what f prime of 0 is. And that will be 2 to the 0 times ln2. And that's just 1, and we have ln2. And ln2 is just a number. It's approximately 0.693 and so on. So just keep that in mind. And then finally, we can just plug in everything into this formula. So ladies and gentlemen, L of x is equal to, we have f of a, which is 1. And then we add the slope, the derivative, which is just ln2, times x minus the a value, which is 0. Okay, so let's see what we have. We just have this times that, and ln2, I'm actually going to put it as, we'll just put it down like this instead of a parentheses, and then multiply by x. This shows you that the x is not inside of the natural log function. So try not to write ln2x, because if you do that, then it looks like the x is inside of the natural log. This is what we mean, and this is not clear, so let's erase that. So we have this, and then of course we have the plus 1. And that will do it. This is it. ln2x, ln2, and then times x, and then plus 1. Done.